Good evening, afternoon, or morning, everyone. Thanks for joining and welcome to the second Sunday discussion that will be about basically CQRS and event sourcing. And we can learn about this from the best, Marco Heimeshoff and Alexey Zimarev. I'm Zsófi, by the way, for those one who doesn't know me. I'm a product manager located in Hungary. And being a product manager, I don't have too much practical experience regarding the CQRS and event sourcing, but I'm very keen on learning more about that. So let me actually pass it over to Marco and Alexey to tell us what CQRS and event sourcing is, and then go from there. And please, everyone, enjoy the discussion and actually feel free to raise questions and raise your hands if you want to say something. So, Marco, Alexey.
Hello.
Hi. So now we have a Canadian standoff, right? Both polite.
Okay, you start with what?
Yeah, maybe you can first introduce yourself, right?
Let's just go. Okay, just kidding. All right, my name is Alexey. I live in Norway, and I do quite a few things, but mainly I do system designs and for distributed systems and telemetry processing and stuff like that. And I do quite a lot of code. Well, right now I do a bit less code than I used to, and but I still quite a lot. Recently I wrote a book about event sourcing and .NET Core. So that's probably why I got invited. And I'm happy to share with everyone what I know and what I learned and what I keep learning about event sourcing, because I'm a big fan of that technique, let's say it like this, since it's not really in the architecture or whatever design method.
Cool. Yeah, so I'm Marco, I'm from Germany, and I work as a programmer and also as a consultant. So I've been programming in the same company for about 12 years now, and I consult companies worldwide on using domain-driven design, event sourcing, CQRS, and other patterns. And I'm particularly fond of CQRS and event sourcing because I've been looking for architecture for years to actually manage the legacy that we're building up for over 2 decades. And with CQRS and event sourcing, it was for the first time that I found an architecture pattern that actually seemed to solve all my problems, until I learned that my actual problems are in communication, but that's a story for another day. But yeah, from a technology standpoint, CQRS and event sourcing is a pretty good go-to model for me. And I know there are a lot of people out there saying it's not the go-to architecture per se, but for me, it became the default. So there are other architectures that I use, but I have to argue for them. The default is CQRS and event sourcing, hence I'm here.
I'd say still that is event sourcing. CQRS might seem as an architecture pattern because it implies certain possible changes in how the system is actually being composed. For event sourcing, it might not be the case. So I would still prefer to call it like a design pattern or something, or a way to persist your data.
Yeah.
Because that's what I try to show in the book, when you go from a traditional persistence, like state-based persistence, to event-based persistence in a relatively easy way. But of course, there might be architectural changes that event sourcing brings with it. And there it becomes the architecture, but the architecture is more or less, it's not really what event sourcing brings to you. It's more or less a consequence of the decisions that you have to make when you decide to do event sourcing and you go to things like reporting, projections, read model, stuff like that.
Yeah, I would totally agree. So for the audience that doesn't know what CQRS and event sourcing mean, I mean, there might be people who have never heard of
split those two, like start with CQRS maybe?
Yeah. I would just start with CQRS. So CQRS is a pattern and it's distinct from event sourcing. Both fit very well together, but you can use them each on their own. And CQRS means command and query responsibility segregation. So instead of building one object model or one code model that is solving your problems of behavior and transactional consistency, as well as querying information, searching, filtering, all those things, you build distinct models. One model to ask questions and get answers, and one model to execute behavior to actually modify the state of your business or your domain. And then you need to keep those models in sync, kind of. That's where event sourcing usually comes in, but it's not a necessary part. So building software with multiple models in mind, so you can have polystructured information on the one hand where you read data, and you can have a very easy to understand, high performing model that can be transactionally consistent without all the baggage of information that you just need to represent on a screen. That's CQRS in a nutshell, basically.
Shall we maybe draw some diagram now?
Yeah, switch.
Because I'm eager to try my stuff, you know. I bought this whiteboard for a purpose. So basically, if we talk about, can you still hear me?
Yeah, we see your screen.
Yeah.
So when we talk about CQRS, we usually mean that, like, you for every system, I mean, make no mistake, there is nothing specific to CQRS. Every system receives commands, right? I would use the notation and the denotation of event storming to indicate, like, there is an action that's being executed on the system, which is a command, right? And there is a user here that works with your system that might be not actual user, it might be another system, but nevertheless. And then you have your domain model. And the domain model receives the command, and it needs, like, there are not that many systems that don't use notation of the state, right? So I need to use the follow thing. So you can see if I move the board. I think I need to use this now. Just one sec. I keep forgetting how to do that. No, it's not the one. Okay, I will just try to align this and draw in here. I don't need to do that. So every system needs to keep state of the domain model somewhere. So we usually use so-called state-based persistence. Let's say this is a database. So the domain model persists the changes, the mutations in domain objects in some sort of database. So the communication is two ways, of course. When you execute a command, it first needs to read something, make a decision, and then write the mutated state back. And when you read something from the database, if you remember sort of domain-driven design style, you have a repository, right? So the repository handles the collection of domain objects like it is in memory, so you can query it. And when you want to see something on the screen, you execute a query, but you usually query the domain model.
Yeah. So that's where most of the pain comes from in most systems I worked in.
Exactly.
Because you have a huge model that needs to gather all the data. And when you just want to execute a quick command that basically needs only very little information, you still have to load the whole object that is also necessary to query stuff. And yeah, that's a big pain.
And CQRS comes from the idea of the read-write mismatch, because there are not that many systems that have equal number of writes and reads. in traditional like business line applications and most customer-facing applications, the balance is you have more reads than writes. You usually look at the screen and you rarely execute commands. So like look at booking.com, for example, people read a lot, but they don't book that much. So it's always a bit different scale of reading and writing. So you read less than write. There are other systems that do the opposite, but we probably won't need to touch them, but maybe when we go to event sourcing, we can do that. So what CQRS says, okay, you optimize your command execution, the persistence for command execution to handle commands more effectively. So what you basically do is that you keep this. So the domain model is still essential to execute commands, and because you need to make a decision. So you need to load the state of your domain object. And when you execute queries, I don't know how to delete it. When you execute queries, let's say I need to just do this maybe. No, it didn't work. Nevertheless, you understand, you get the idea. You build a separate model, which is the query model. And you query it instead. So the idea of the query model, it doesn't need to match the structure of your domain model. And the first stage of CQRS, if you use the same database, and the same way to persist the data, but you get detached from repositories, from all this complexity of the structure of your domain model, and you just say, let's say it's SQL database, right? And you use something like Entity Framework or other ORAN tool to manipulate your domain objects, because it's pretty easy to do. But the query model doesn't need to work that way. So when you have a screen and you need to show fields from different domain objects, you don't execute thousands of queries because your domain model forces you to do that. You just execute a SQL statement and you read directly from the database and you get your data. That's basically the idea of CQRS. On the next stage, however, when you move further, that's where many people stop, and that's totally fine. What we do is instead of doing this, we will, let's say, I actually don't know what's happening, but nevertheless, I will just move and build another one.
Yeah, so just to jump in with some experience on that, when you start separating your models, the very first thing you can also do is, if you have an SQL database as your backend, as your data store, you can write views on that, because if you separate commands and queries, the front ends, they don't care what your model is, if you have one model or two. But if you have a view, you can have a read model or a queryable model that you optimize for the query at hand. You can have persisted views that are pre-projected whenever data changes and not joined whenever you need the information. And that gives you a very easy first step to actually separate your models. Yeah, so that's CQRS without anything else, just having separate mental models that you persist in a structure. So you have a domain model and a queryable model in view form. It's a pretty good idea. If you have a legacy system in place already, you want to get to a CQRS implementation. People are usually afraid of, okay, how do I start CQRS? Do I need to have a big bang rewrite? And that would be really bad to try, because rewriting a whole business software takes ages and might never get done properly. But if you can just start with a new query model for a new screen you're building by just having some views and then optimizing from there, that's an easy and painless start to get from where you are to separating your models.
So the idea that comes next is that you keep the domain model talking to a certain way to persist. It still might be the state-based persistence, like a SQL database or document database, but you keep your domain objects. But when it comes to the querying, so what you do is then query returns a screen to the user, right? Some data that the user wants to see on the screen. And then from there, in the query, you use the query model, which resides in a different database. So the question arises, how data from the domain persistence gets to the query model database if it's a different database. So from the idea itself, you can understand that you can optimize not only the model itself, but also the persistence mechanism. Like, for example, you can use SQL here and a document database here, or the other way around. And if you can find a way to reliably produce changes or replicate changes in your domain model to the query database, you might figure out that you are not limited with having one single query database, that you might have another one here on the side, which is a query 2. And if you propagate the changes from the right side, as we call it, to another database of some sort, you can have another query over here that uses that optimized persistence to do something else. It's another query.
I think the screen share is not synchronizing.
Yeah, I see that too. It sometimes happens with Miro. So it actually it stopped at some point. So, but you can probably see it just behind me. It's over here on the screen. So
yeah, we are two.
I think I just need to wake up my iPad because that's where the sharing is happening. And now we can see it.
Okay.
Right? So I just need to keep it awake. So the idea here is that basically imagine that this is document DB, for example, of some sort, for example, MongoDB, which is quite nice to persist domain objects because they usually have a rather complex structure. This can be SQL, for example, because you might want to execute some complicated query with joins. I'd rather not to, but for example. And here you might have a graph database, for example, or cache, like Redis, whatever else. The thing is that this part over here is pretty hard to do. No, not there, of course. Here. So these synchronization links are not easy to implement. And the reason for that is that there are many places where people make mistakes, and maybe you, Marco, can tell about the consistency stuff.
Yeah, so we've suffered from this when we started separating models and not using event sourcing at first. We thought like, yeah, let's just take a second database where we persist the model that we want to query. And that's a great first take. And starting with views was painful because you have a lot of performance issues then. So having an actual persisted second database is amazing, but you have to denormalize your initial data store. And whenever something changes, you have to react on a trigger or something and actually project into a new data model or multiple data models that you persist in another database. And once you write that, it runs smoothly. But when you have a problem, when there's any mistake in the projection and your querying data model is broken or is not correct anymore, you have no way of getting back to the actual state that needs to be in there, because the domain database, there's a lot of updates and deletes happening. So you lose information whenever you delete, of course. But even when you update a table, you overwrite information that has been in there at first place. So there is no way of getting back to the state that you actually meant to have. That's a big problem. And the other one is you don't want to tie those two databases into one single transaction, because otherwise there are multiple database systems waiting on each other. What you want to do is your domain should execute as quick as possible. And
might not even be possible, right? It might not be even physically possible to wrap them in transaction.
Depending on deployment issues, there might be physical reasons why you can't do it. So it's not always two databases in the same system. So yeah, when there's no physical way of guaranteeing transactional consistency, you need to work with eventual consistency. So at some point, the database will be consistent, and then you can query the right data. You can get notified and whatever, but it becomes really cumbersome if something changes and there's a script that has to analyze through lots of tables what actually happened, what changed in here, and how do I represent this in my new query model now? Because if you just have data to interpret, it's hard to get to the reason why the data happened. And
I have something to add here.
Yes.
I'm interrupting you, no?
Yeah, it's fine. Shoot.
Okay, sorry. So what I want to say is that you can still do it. Like, I don't want to jump to event sourcing prematurely. The issue here with this red that was not the idea, smart drawing thing. So the issue here is a big exclamation mark, is that when you go to, if you can establish transaction between different kinds of databases, imagine this is a document database and SQL database, you can start thinking, I have a transaction update using distributed transaction. That's actually something that you should not do, because it's really bad. It's two-phase commits, and it quickly escalates to three-phase commits in the middle of the night, and that's the situation where you don't want to be. So what some people do is that they use message brokers. So they put a queue here, and they start updating these two read models from the queue by listening to domain events. So here we come to the actual concept of domain event, which is not related to event sourcing whatsoever, but on every command that's been executed, you publish a domain event. So what I issue with this, if you just put the domain event to the queue, the thing is that the message broker is just another way to persist the data, although it's transient. What you get is you have one operation that is being executed on the database, and the second operation is publishing domain events to the bus. And there can come a lot of pain, because usually it works, but if it doesn't work, what happens is that you keep the consistency boundary over here, which is correct, which is where your aggregate lives, but all your models might eventually get out of sync, and they get out of sync forever. So it means until the full update of this model would ever come, you will not have updated updated data or state change in one of those read models, or both of them, if you say it like this. Another issue with message brokers is that message brokers never guarantee ordering. There are tricks to do that, and different message brokers offer several ways to kind of simulate guaranteed ordering. But and again, if you don't know this and you haven't read or experienced this in your real life, it might even not happen if you just say, I have one single consumer that consumes that message. I don't want to parallelize. You lose scalability, but that's okay for the start. What can happen? For example, RabbitMQ is notorious when it goes to partition state. If you cluster disassembles and then it's assembled back, you might get the same message twice, or you might get some messages later than those that you processed previously because they got to another node in the cluster. So what happens is that you get domain event 1 and then 3 and then 2, and the update number 2 can actually be preceding the update number 3, so it has less relevant information. That's actually the previous update, and you can override the actual update with something happened before. Again, this is a guaranteed way. At some point, it can work for years. At some point, your read models can become inconsistent, and that's the biggest danger, because of first the idea of two-phase commits, so two operations executing sequentially. And second thing is, of course, that using message queue for populating read models is not a good idea. And I get this question a lot, and I wrote it in the book, and I write about it in Stack Overflow. But with regularity that I envy, actually, this question comes again all over. So for those who listen, please don't do that.
So On the chat, someone made a statement. You can create read models with event sourcing, but it will lead to big pain. Therefore, read models are not part of CQRS, but event sourcing. So is query models, should you do query models with CQRS? Or is it in CQRS? Or is just a...
Yeah, that is...
the wrong dialogue or the wrong discussion?
No, I get the question. That is kind of like a definition question, right? When you say CQRS is command and query responsibility segregation, then by definition, it's part of CQRS. If it's a valuable thing to build, depends on your problem that you have. So when you say you have a small transactional domain model with easy behavior or with distinct behavior, but you have a lot of information from your system that you need to be projected in either graphs or relational data or other things, then reacting on the domain events and saying, when this happened, I want to project it into a certain state, can be a smart thing, can be the right thing to do or the only right thing to do, could also be totally wrong, but that totally depends on the specific content of your domain. So as a rule of thumb, when you have big data, when you have, not big data, but when you have large information, when you have, for example, big PDF files or video files that you want to edit and change, that usually is not done with event sourcing. You wouldn't publish an event saying that pixel moved to here and this part of the image moved to there. You store a blob in some document store, but still the event that the document changed is something that might be meaningful to someone who looks at another screen or to some notification. There might be people in the business relying on that information. Oh, this changed, now I have to react, people or systems. So I would say that a query model or read model is very well part of CQRS because that's the nature of CQRS, distributing your models, having different models for different purposes. And event sourcing is a good way of filling up the state or projecting the state of a domain model when there is semantic behavior involved. So when the events are of a meaningful nature, when something like customer moved to new city, holiday has been booked and stuff like that, from this semantics, you can project almost any state because you can interpret it semantically and just do whatever you want with it. Yeah, I hope that answered the question.
I have something to add. Basically, speaking of definition, I would like to return to the very old presentation made by Greg. So this is the CQRS that he talked about when it was defined. So you have a single data store, you have domain objects being persisted to the store, and then you have the thin read layer. That's what I think the question postulates, like you just read from the same store. Essentially, the next slide shows that you have two data stores where you split and eventually put or project changes to that storage. I don't think this is a direct way to event sourcing. There are many ways to do it without event sourcing. The most obvious way to do read models without even engaging to events or going to event sourcing world is tracking database changes. There are numbers of databases that support change tracking. Even SQL Server, which lags behind in most ways, has a data change tracking since version 2007. Postgres has tracking changes since they introduced clustering, and they made part of the clustering mechanism available also for external consumers. MongoDB and Cosmos DB, they all have changes that are the change feed stream that is not the domain event. It just returns you every single change that happens in a database, so you can update your read model with that change. So if you ever worked with Amazon DynamoDB, basically DynamoDB is key value store on steroids. It's very scalable and it's very fast. It's also pretty expensive for the key value store, I must say. But if you read the documents, the paper about Dynamo, they have these questions regularly. How the hell can I get this thing, key value store, if I cannot query by that key? I need another key. when you have a key value stored, the only thing you can do is query by that key that you already have. So let's say my domain model is stored in Dynamo, and the key is my aggregate ID. So eventually I can't query it anymore, because the only thing I can get is a single object. So what Amazon says, without mentioning any event sourcing, without even mentioning CQRS, what they say, you have kinesis streams, you stream your changes to another Dynamo database with transformation between, and build another database with another model that gives another key. And from there, you query what you want. And if we need multiple of those, for a single screen in your system, you might have another database that listens to the kinesis stream of changes in the first domain DynamoDB and projects them to the read model. It has nothing to do with event sourcing.
Yeah, totally.
Read models, essentially, and I'm answering that question directly, read models can be built without event sourcing. Although building read models with event sourcing is not that painful that some people might think, at least what I experienced so far. So I want to say that both patterns are pretty valid, and we know there are tons of customers of Amazon DynamoDB that use exactly the same pattern without naming CQRS, but they essentially use that.
Yeah, so if I understand that correctly, that means a read model is any model that you process data in that is distinct from the domain model, right?
Basically, yes. And if you split the read model and the write model physically or logically, it doesn't really matter. But both ways can be done without going to event sourcing.
Yeah, I agree.
Okay. Then another quick question. What makes CQS different from CQRS?
No, that one is simple. CQS is for objects. So if you have it's a Bertrand Meyer, I think. It's if you have an object, any method on the object should either change something in the object or it should give you information back. It should never do both. So that's command query separation. And that is per object. And CQRS is per domain or per model. So it's a culmination of multiple objects that work together. And then you just apply the same logic, saying a domain model should either execute behavior or a object model should give you back information when you ask for it. So you lift up the thing that you do for objects, the CQS, to an architectural pattern for your whole domain or your whole model. And that's what CQRS is.
I think CQRS per se implies having a persistence, and CQS has nothing to do with that. It's just how you form your domain objects or objects in general. Let's say if you move to functional programming, there is no single function that doesn't return anything. It always returns something. But there are pure functions, and there are functions that have side effects. So basically, commands always have side effects. They should not return you information, although I would argue that sometimes this principle is not that hard-stoned. Let's say it like this. That's probably not a good word, stoned, but not written in stone. But pure functions is a perfect example of queries, in my view.
Sorry, can I also step back here and ask when to use CQRS and when not to use? So if there is any specific situation when you would say that don't use CQRS at all, don't separate your commands from queries. And
okay, I'd say if you don't, let's assume you have a domain model. Let's start with that. If your domain model literally represents one-on-one the model that you show on the screen, that you probably don't need to use CQRS. The point is, if you do that, most probably you can just go along with CRUD. You don't need a domain model as such, because the read model is usually a combination of several, well, the result of pieces of state from several domain objects. It's rarely representing a single domain object. So that's, by the way, one of the things when we get to event sourcing, I would say something about snapshotting. If your read model is the same, I mean, what's the point? You can just as well query your domain model and write a couple of methods in your repository, whatever you call it. But if your domain model is distinctly different from the things that you show on the screen, which is most of the time the case for most of the systems, I'd say CQRS can be used and should be used everywhere, because you are optimized for what you do. If you execute commands, you optimize for writes.
Yeah.
If you run queries, show information on the screen, you optimize for reads.
Yeah, so in my experience, using event sourcing is something that you don't always do. That's a bigger decision, but CQRS is kind of like my go-to pattern, because if you want to build up a screen, the question you ask and the data you need needs completely different state than if you want to send a command, unless, as Alexey said, it's a CRUD model and it's just the same data. But that normally never happens, only in very, very trivial domains. And even if that happens initially, conceptually, it's two different models, so they might change at different rates. But if you tie them together too early, because you say, oh, look, it's the same thing that I'm looking at now, that I also want to modify. If tomorrow someone says, oh, I have another need for the view, or the behavior needs to change now. Now I have one model for both purposes. And if I change my behavior, I have to retest my querying and my UI output, and those things are not the same. So I usually said when you do a prototype, when you just want to quickly prototype something, build it any way you want. Just, make it a CRUD thing or make it a simple domain model that can also be queried nice. And once it goes productive, you have to separate. But in reality, the pain is always so high. After 2 or 3 days of working with a 3-people team, you already have so much code that if you have to separate now, it just becomes painful. And for me, it's not about adhering to the pattern saying, let's say CQRS is always good, so do CQRS. For me, it's about the simple thing of asking why and what you actually want to do. So if I say, I want to show you this information, define this information specifically, great. Now you have your data model that you can query. And if I say, oh, look, this behavior needs information, like I want to order something, but I can only order it if it's available. Cool. So the only information I need is ID, amount, and is it available? Nothing else. So if I build on those simple things, I don't build with what I have, but with what I need, then I get the simplest possible model. And in the long run, this keeps you sane. That's why CQRS is for me an always go-to method. I always just build the models I need for the purpose I have. And event sourcing is optional if it actually adds benefit, which it often does, then I add it.
Cool.
Okay.
We have Adam.
Yeah, I'll allow Adam to talk and jump in now. Here we go. You're on, Adam.
Hello, Adam.
Hello, Adam.
Hello, Adam.
Can you see me?
Nope.
Well, we can't. We will not be able to see you, but we can hear
That's
you.
really a good thing because I didn't shave today. Anyway, for the go-to thing, when to use CQRS and when not to use CQRS, I see CQRS and event sourcing as tied very closely together. Simply from the point of view that I'd like to peel back everything that we learned in industry and look at information systems for what they are. I think the question in terms of when to use CQRS really depends on who's asking and who is going to be doing the work. I believe if you have a team that's strong in traditional development and senior development is available, you certainly shouldn't use CQRS or event sourcing because it's a tooling question. However, if you are at a startup and you're starting, CQRS and event sourcing, I'm going to lump the two together. I know you guys don't like that, but I do see them the same as the same thing quite a lot for a couple of reasons, is that you have the ability to record everything that's going on, even though you don't think you need to optimize for query and read. What you do have is with the event sourcing side, not losing track of anything. And so what sometimes CRUD things are used for are those very simple things, but those very simple things are usually at the start of a project when there's a lot of flux in the understanding of the business. And the best thing you can do is to record everything like an accountant in terms of what your thoughts were as to what's going on. And even if your events are really primitive and are really just snapshots of state, at least you're being very good at accounting. Now, your read models may actually not be very complicated to do because you're not optimizing for performance and there's nothing to do with optimizing different databases to coordinate different views. So they can be ephemeral. They can be simply things that are calculated on the fly when you inspect everything that you recorded. And I use the typical example of someone that's really experienced in programming versus someone that's not. It's easier to actually teach someone that's not experienced a way of working with CQRS and event sourcing because you can allow them to simply record on a ledger. You don't have to use that word, but you just say write a file when something happens as to the fact that this happened. And then when you want to show something on a screen to satisfy a query, can you get that information by looking at what you've written down to disk? And usually the answer is yes. And usually the answer is actually simpler, because most likely those people that are starting to use event sourcing are probably doing some events that are bloated. They're not following that third normal form purity that events should have. So in fact, their start with event sourcing and CQRS is going to be easier. So when should you not use CQRS? It's probably a political question more than anything. If you have a set of people that are already used to that, they're fresh out of a regular kind of boot camp and they just want to do Rails and you for everything, you're not going to really gain much by having that simple start or that simple application be done with some other concept. You're going to be really taking away the tools that they really learned, and Rails new is going to be their go-to thing. However, that obviously, as Alexey already mentioned, has a limited shelf life, and Marco as well. As you start to change the behavior and all those things that you thought were going to be all you need in your CRUD, you quickly realize the handshake you made with the devil and how your models and structures and tables are acting as cement around your feet to quickly change, and you become very quickly less agile than you thought you would by using these tools that on the surface got you going so quickly. So when to use CQRS ES is really a question about what type of team you're working with and who's available. A lot of times the business people are the easiest to convince of event sourcing and CQRS because it makes sense from an accounting perspective, and it makes sense from an information preservation perspective, as we already covered with the updates being deletes. That's something that's really understated in the industry, and actually lets a lot of bad practices pass through unnoticed. So yeah, that's my take on it, and I hope we get into the ES part, because I think CQRS and ES are.
I just have one thing that kind of combines, answer the question, how should we convince the team or admin, I don't know what admin is, but probably some management to use CQRS? I would say you don't. So I'd like to share my screen again. And
thank you, Adam. I will. Oh, you're already muted. Thank you very much for the comment.
I unmuted.
Yeah, thanks for it.
Thank you,
Adam.
Okay, thanks.
And thanks for
joining. Very helpful.
So what I wanted to show is about, like, let's say we have a more like traditional system. What Adam said, that probably he wouldn't use CQRS. I'd argue that it might not be always the case. So let's say this is the user, and this is your application, would be web app in this case. Let's say like it could be a mobile app, and it talks to the database, right? So commands are still being executed and queries return the data. That's inevitable. That's how systems work. So, and this is your big thing that's called the legacy database. And eventually people start to wonder how we can make it more structured in a way that we keep running SQL queries here, and we can run SQL queries here. And this becomes really hard to manage, because basically we don't have operations as such, but we do have a lot of updates, so we might even shift them to store procedures. And nothing against on procedures, I might have, but that's not the point. The point is that the team might need to say, I want to have some sort of domain model, because I want to make sense of things, because I'm working with the business and I want to model my business. I don't want to model my business in SQL. I want to model my business in a meaningful way. So I have methods like book a room in a hotel instead of running a SQL query or SQL update. Because usually when we deal with legacy systems, there's a lot of business logic over here, and over here, sometimes in form of stored procedures. And people get quickly fed up when they actually start doing refactorings and stuff. They can't do that much. So if you build the domain model on the side, which represents your business, that's the hard job in itself. But let's say you have started doing that, the question will arise, okay, I execute my commands in the domain model, and the domain model writes and reads from them to the database. So what happens next? I'd say do not try to put everything in those bloody repositories. Try to skip them and keep using. So you scrap this thing, but you keep using, oh, this needs to go. You keep using this one because that's essentially your read side. So you say, I want to use domain model. I want to use, or okay, and let's not talk about ORMs. That's the easiest way to do that, but still. I want to still persist to the same database. But if you do that, and if you start rewriting everything at once, it might be pretty hard to do. But if you just push commands to the main model, commands execution, making decisions, taking decisions based on the information that's stored in the database, where you essentially work with the model only, but you keep the rest, keep your screens being populated from SQL. No problem. That's CQRS already. And if you want to move on, expand this model using different techniques, that's a different story. But that's already CQRS. So basically, like Marco said, the best rule of domain-driven design, do not mention domain-driven design. You can use the same technique with CQRS. You just say, okay, let's do the domain model where we execute when we mutate the state, but we do not ask information from the domain model.
Yeah. And I would want to expand on the question, like, how can you convince people? As you already quoted me, don't talk about CQRS because it's not about using the pattern. It's about what you want to reach with the pattern. So one very easy thing, or one very valuable thing to do with CQRS is if you have a legacy app already, if there's an application with a huge database and everybody's using the same programming style against that database, taking CQRS and event sourcing, maybe just CQRS into account, you can build a new part of the domain model. You can build a new domain model that whenever something happens, it projects into its own read models. And then one of the projections is just the old database. So I don't have
That's event sourcing.
Yeah, that's with event sourcing. I don't have a screen sharing tool, so let me share my idea here. Not mirrored. Well, but if you have your task-based UI and you send commands into the domain, and then the domain emits events into the event stream, and that projects into multiple new great read models for your new UIs. The legacy is still also just a read model. So when something happens with event sourcing, you can react on that and actually edit the old databases like the old feature did when it was still active. And if you have that, then you can choose for your commands, for example, when you say order something, the old users, everybody can just use the old domain model, which is basically just SQLs probably. But some users that are experimental users, they can already be queued through the new domain.
Can I interrupt you, Marco? Can we move to event sourcing first and tell people what it is? And then we talk about read models and integration and legacy systems as read models.
Okay, sure.
Yeah, because I just wanted to mention, if I hear out correctly, that's less straightforward in terms of event sourcing, right? When to use or when not to use. So we can jump into that right now if you can.
There are more arguments to consider.
Let me just wrap that up. Let's not get into event sourcing too much then, but the question of how to convince, that was the idea. You don't have to convince if you can show that you can generate new value where you had your hands tied before. So because if you get like immovable at some point because your legacy becomes unmanageable and nobody can really change anything in a meaningful manner, CQRS enables you to use the old system as part of the integration and builds an anti-corruption layer, so you can build new domain models and new read models on top of that by integrating through the means of Q event sourcing. Hey, Alexey, let's talk about event sourcing.
Yeah, let's do that. When I started with event sourcing, after it was quite a few years back, and I think it took me a couple of months actually to understand what it is, because there was so little information and so little blog posts and examples and stuff like that. I didn't even catch this, or I didn't even see this MR repository, the famous one from Greg. And so from that experience, I understand that it might be not that easy for people to grasp the thing, what it is. So for me, it's a persistent model, essentially. Like, I know what Adam going to say, well, more or less, but it's still, you replace the state-based persistence with sort of behavior-driven ledger-like persistence. So instead of persistent state of your object every time it mutates, you add up all of those changes, all the things that happen in your domain model to a long stream of events. And when you need to read the state of your domain model, instead of going to some place and reading the snapshot of the domain model that we used to in the persistence-based systems, you read all events and reconstruct the whole thing. However, that's where Greg has started. That was the original idea, but I think currently the dominating definition of event sourcing is that if you build a system where every update is, where every state mutation of the whole system or part of the system is persisted as an event, and potentially the system can be reconstructed from reading these events, it is an event source system, but it doesn't need to be always reconstructed, or neither the whole system nor part of the system needs to be reconstructed for every single operation. So instead, you still keep a snapshot of your objects or the whole system and work with that in order to, like, you still use the snapshot as a source of truth as in traditional state-based management systems. But again, the snapshot itself is produced by projecting events to state mutations in that sort of snapshot. So for me, it's clear, but it might sound a bit cryptic. So I don't know if we need to draw something again.
Yes, I want to add on that. For me, I mean, you're totally right. It's a different kind of persistence. I totally agree on that. But the most meaningful change that I had when I started using event sourcing was that you don't lose intent anymore, or you don't lose semantic meaning of why data changed. So instead of storing a state where you just know the state of something, you actually can read the whole history of your domain. And there are simple examples, like when your address changes, could have changed because you moved or because an error was corrected. If you just see the different data, that doesn't add meaning, but this meaning could be meaningful for the business. So event sourcing is the very first take on the very first structured take on persistence, where you actually don't lose anything anymore. And the only downside would be performance and or the size of the store. Size is not a problem today, and performance is something we can explore now, because that is actually not that big of a problem if you use it correctly.
Yeah, I think what I mentioned in the book is that for me, event source, we keep talking, and in DDD sort of bubble or DDD community, we keep talking about concentrating on behavior. So we do not mutate state. And our systems are not built to mutate state in a database. That's a side effect. What we build systems for is solves people's problem, right? And we do it in a way that people look at some information. Remember probably I need to find it actually, but it might be a good idea. The picture that explains almost everything. Remember that, Marco?
Yeah, I remember that.
So I will find it when it will be your turn. So I will show it on the screen. People look at the screen. Let's say your system always works with people. So they are your main users. They look at the screen, they see something on the screen. Get this example of Booking.com. I try to find a hotel to stay next year in Italy because of some event happening there during summer. And I searched the dates. I entered the place name. I enter the dates and I specify how many people are there. And then I press search, so the system will go to some place to execute a query and return me the availability of those rooms. This was informational part. I haven't done anything. I mean, I got information, but I haven't changed the state of the system. When I place a booking, I reserve a room, then the system state has changed. We do not, well, it's again the question of semantics. You might argue that, of course, it's like quantum physics. You observed it and the state changed because there are some metrics and log being produced. But that's not a business. That's technical concerns. So when you actually book a room, and especially if you paid for it, there are a lot of changes happening in the system, but they are not updating your database. They are not mutations of the state. These are actually business actions. And you want to be able, and when you have a domain model, you have a method probably in your aggregate root or say whatever entity that says book room, that supplies you the guest details and all this information you need to have. And you have a method called accept payment, and you have some reactions on that saying payment was accepted or rejected. And then based on that, you make other decisions like keep the reservation or mark it as fully booked or paid. You might have consequences that the hotel became fully booked and you need to close down the reservation, not show it on the screen as having capacity for that particular period of time. A lot of things happen, and this is all behavior. These are all pieces of behavior in the system. I would argue with state-based persistence, when you mutate state of the database, and that's the only thing you do, you don't work really with behavior. The behavior stays in your domain model, but basically you call the object method, and that's all history you have. You basically have none. So as soon as you change, you log in again, and you see no capacity for that city, for that hotel, and that dates. You don't know how this happens. You just know that the capacity is 0. Imagine you log into your account in a bank, and you see 0 money. I think that example comes from Bragg. You call the bank and you say, look, where is my money? And they say, I have no idea. Did you even have money? I say, yes, I looked at it yesterday. Well, whatever I can say, you can say whatever you want, but how your system displays me the account balance? Yeah, we have a huge table that says account number, balance 0. That's it. Thank you, bye-bye. So the mighty table in the bank says that it's 0. That never happens. Banks use transactional ledger as well as accounting for decades. It's not even years. It's not like new tech or something for them. They might not call it event sourcing. They might do different terminology, but that's basically ledger-based system. It's been there for years. And because otherwise, you can never trust a snapshot. You might use it for reading purposes, like showing information on the screen very easily and fast, but you never use that to make any decisions. So, and with event sourcing, for the first time, we're working with real live systems of general purpose, not the banking, not accounting only. We got a chance to persist pieces of behavior. So when I do booked room, and the capacity wasn't, so my system domain model made a decision that I'm allowed to do that. So I have the capacity is there, and I meet the age requirements, whatever requirements they have. They might be how many nights, the minimum amount of nights I can stay, number of nights I can stay, and stuff like that. All these conditions are met, and then I say room booked, and that's the behavior. So the behavior gets persisted, and I can see the full history of what happened with that reservation and what happened with this room, because the room might not have event like room booked. It doesn't need to. It might have the capacity has changed for that period of time. I don't know. I'm not in that domain, but I might imagine so. So in my view, that's very important. That's the point we talk about behavior, that our user interfaces are behavior driven. Our domain models are behavior-driven. We need to concentrate on behavior when analyzing the domain. We need to understand the behavior when we actually implement the system. But somehow, for many, many years, on the last possible moment when we persist, we didn't care about behavior anymore. We just say, okay, we changed the system there. So I worked in one company before, and we got this nasty error when the inventory didn't match. There was inventory in the warehouse and inventory somewhere else. They didn't match after receiving a batch of goods coming on a big truck. You know, I worked there for 3 years, and for 3 years we had a script of like a list of SQL statements that we need to execute, because there were a couple of potential causes of this issue and how to fix it. We never were able to find the cause of it because we never had a possibility to go to the persisted behavior. Let's say like there's a sequence of decisions that have been made on the domain model and find out which decisions got the wrong information, why this mighty table indicated in one place it were 3 items, in another place it was 2.
Yeah.
So
I think that's one of the very strong suits of CQRS as well. So if you have an error, and usually you have to analyze state, it's like a crime movie, right? You just see the crime happening or happened, and then you have to figure out who was the murderer, and you're trying to you go on a hunt and gather all the clues. And even the software we're working in, where a lot of the software is event sourced already, all the parts that are not make it really, really, really hard for the people to actually find the bug, find out what happened. Sometimes an error gets reported a few days after it happened, and then there's so much other information happening afterwards, mutating the data already again. So you lose a lot of intent and a lot of things that happened. And it's really hard, up until impossible, to figure out why the data isn't there or isn't in the way it should be. If you have event sourcing, that becomes kind of boring because you can just read the story. You just read the history or the audit of everything that happened, captured in domain statements. And that what makes it pure bliss for supporters. So if you need political backing in your company, you have even easier support afterwards, and the bug hunting people have an easier job because you can just replay any state and just read through it, whatever happened.
Just don't get us wrong, because there are a lot of sort of arguments against using that particular sort of use case for event sourcing alone for advocating event sourcing systems. There are multiple ways of implementing tracing of this kind of stuff, especially if you do have a domain model, if you do publish domain events. And we talked about the consistency issues in using message brokers for populating read models. However, you can still use message brokers to distribute information to other parts of the system for integration purposes. Like if you have several bound contacts talking to each other, that's kind of default way to integrate using messages and publish subscribe technique. However, and that particular one can be used also to record the audit log. And audit log alone is actually quite powerful. Another argument that I heard against using event sourcing in that regard, like tracing back the errors, it's like if the data in the event is incorrect, you won't be able to find out why it's incorrect. I'd argue back that this is a different problem. The problem of your domain model producing one event based on a different or wrong information or correct information than we put to that, it's one thing. So it's, I would agree, of course, that there are two sides of story, of course. First side of story, that users will never admit that they've done something incorrectly, like they entered incorrect figure. So we missing some validation or missing some checks will allow users to do something that they're not supposed to do. But this is something that comes to your domain model. If your domain model produced a domain event and this domain event has a correct data and your state in the read model is incorrect, there you can trace. But you can save commands as well in some other way, like using the audit log. If you use messaging, for example, for executing commands, you can easily do the audit log as well. So combining these techniques give you a really powerful way to fix that. And there are cases like we were talking on Twitter recently, like my events are incorrect. What do I do? Well, first you figure out why they're incorrect. If you know why they're incorrect, then you can rebuild them. If you know why they're incorrect, you can do the corrective action. That's pretty normal. You just emit an event that says, I correct this because this happened. So it's not a showstopper at all, but at least you know what's going on in your system. So I completely agree with Marco that gives you a lot of visibility and brings you new insights. And essentially, it makes the fixing of the domain logic pretty easily. And this is how systems that are more DDD flavored, when we read the aggregate state by reading all events from the aggregate stream, a bit more flexible than a sort of event and snapshot based system, and the snapshot is used to take decisions.
Yeah, and I would even add, if you use the events as a source of your state, then you can't forget to produce something just for logging. If you just have events emitted so you can analyze later, they can be modeled wrongly and in a stressful phase, or if the testers don't really check it, or whatever complexity your system has, when they are not the same, you lost information because your state might be correct, but your logging information is wrong. If you use event sourcing as a simplest possible solution, then you have your audit and it's the same as the state of your domain. If there's an error, it will be logged and it will also bring you a wrong domain. And the next beautiful thing, if you use events as a source, is when there are wrong events or when there's an error in your system, you can quickly analyze where the error is in the domain model or in the projection. Because you just look at the events. If the events are correct, then you know the projection is wrong. And all you need to do to find that error is take all the events, project them, and look at whence the error actually occurs in the read model, and then you can step through the projection. And if the error is in the event, you play back until before the event happened, replay the command if you stored them for support purposes, replay the command the user issued, and you can actually just step through the live domain. Oh, there it is. Yeah, so if you use the actual event stream that your domain produces, the rest falls into place pretty easily, and you don't have to do some extra work to make some logging happen. So that's a huge benefit, making the impossible or the unwanted states impossible to happen.
Yeah. So this is the picture I was referring to. It was Alberto Brondolini, the inventor of event storming, shows this on every event storming session or before that. So when the user analyzes or uses information on the screen that your system produces, which comes from the query, and information from the real world, like I have certain needs, I want to do something, and I have information on the screen that helps me to make decisions. I execute a command on the system. Command comes to the domain model, and the domain model produces an event. Events then come to the read side of the system and produces a new read model. It actually amends the state of the read model. That's being presented again to the user, and the loop continues. I have never seen a system that is not following this loop. Basically, that's how it works. So I don't know if we need to go to the implementation details, like what are aggregate streams and what are we actually talking about. It's hard to understand the need of the audience without knowing who is listening. I know that Adam doesn't need to, and Ben and some other people.
I don't think we have the time now, but
yes.
This sounds a very interesting topic for next time, I think. So back to the previous one you just shared. So from a product person perspective, I was exactly thinking about that whilst you were talking. Like, what is the best way for a product person or for everyone to get an understanding on what kind of events we have, what kind of commands and queries at all. But I guess one answer could be like event storming with the visual patterns in that and the right people in the same room and talk about that, right? So architects and product people as well, and we also can have an understanding on that.
Yeah.
That I actually used in my practice, that when we do talk about domain events using event storming, or try to use Adam's event modeling technique, which Adam is raising the hand again, then we quite quickly indicate what the read model needs to contain and what events we need in the system, what commands we need to execute on the system, how commands are being translated to events, what information we need to present to the user. And the flow just goes. And when we talk to people, like I implemented this and this, and my event, for example, doesn't contain that information, but I need it to show it on the screen, they grasp it. They actually can understand what I'm talking about, which is very hard to do when you start talking about tables and foreign keys. This is completely different. Although I struggle quite a lot with a different kind of product people that have IT background. These people usually have some experience with relational databases, and therefore it does more harm than good for me, because they keep talking about tables and records and columns. And I try to persuade them, actually stop talking about this. This is a solution space. I want to shift you to the problem space. And techniques like event storming or event modeling bring you to this link, the problem space and solution space together, because from the event sourcing model that you produce on the whiteboard or on the wall, you can rather easily, well, I would say that's not that easy, but it is more straightforward to go to the implementation than with the state persistence based model.
Yeah, and I would say the more you do it, the better you get at the gut feeling and heuristics of if you get your events right. So your first event storming will not reveal the events you want to persist in a perfect way. But once you try working with it and you realize what doesn't work, if you get more experience, it doesn't take much. After a few sessions, you'll have a gut feeling of, okay, this makes sense as an event to persist in state. And for me, the key was heuristics. I think Rebecca Wivs-Brook was talking a lot about it, gathering heuristics of asking the right questions to get to the right events. And like simple things, whenever someone tells you like, oh, this needs to be changed in an SQL database, what actually, sadly, most people do all the time, and that hurts if you're trying to model a good domain. And then even the business people are talking about databases. But if they do, just ask them, okay, what needs to happen so this information changes? And then they say, oh yeah, whenever someone bought this and that, then this table needs to get updated. Great. Whatever they said after whenever, write that down as a class name and add the information that they want to change. That will not be your perfect best event, but it's a good start to get events, and then you can model around those. So find heuristics that work, and asking questions like the why question or the whenever this happens question, they help you to get to an initial model that you can then refine.
I cannot agree more. So I'm going to wrap it up here unless anyone has any objections. I guess you guys could talk about that a lot, and I learned a lot today. So at least for me, it was like 90% pretty brand new information. So I really want to thank you for that, and the audience for joining. And the recording will be available. And enjoy the rest of your Sunday. Yeah, of course.
I see that Adam has raised his hand. Maybe we just can invite him to say what he wants.
Sure. I just see it now. Yeah, sorry, Adam.
Yeah, I'll add him.
Thank you.
Hello again.
Hello. I just, Marco, there's a very important point that Marco raised about the legacy systems. And I don't know if Marco or Alexey can pull up that legacy stream that I have at the bottom of my article. I think that might help to show over a timeline what Marco showed in his diagram for the legacy system. When I met with Marco in Seattle a while back, we were talking about this over dinner, and it was kind of at that point really up in the air how to best show that. But I think most people are dealing at some point in their careers, or sometimes mostly, with legacy stuff, and they have to introduce CQRS and event modeling and integrate new systems with that. So I don't know, Alexey, if you can pull that that diagram from my article at the very, very bottom.
Trying to find.
Yeah, if you can find it, that kind of shows exactly what Marco was talking about, but allows you to add one more piece there, and that's how to also not only extend a legacy system, but also like fix a bug or whatever. If you think about it in terms of what we added to the conversation, which is event sourcing and event-driven approaches, how much more simple that is for business to understand, and then also to get something that's the one. So you can sort of see the old system and the new system. And what Marco was talking about was the last in the adjust user part. Adjusting the old system. So I just wanted to bring that to attention before we left, because it's a really awesome topic, and I'm glad that Marco brought it up, because we can talk about these theoretical things, but a lot of times it really is about dealing with what people are struggling with, which is existing systems, and very few have the luxury, unless they're willing to go do a startup and live frugally for a while. They're usually dealing with these legacy systems. So the more people that we have that understand how to rein those in and give confidence to business to be able to treat them in such a way that I think that's really great. So I would like to thank Marco for bringing that up and bringing it to attention.
Yeah, I think I'm quite sure all of us can talk about event sourcing for hours. I mean, and there are quite a lot of things where we can point to the positive. To pros of event sourcing, I have a number of cons that I would warn people not to do, and where not to use event sourcing in general and stuff like that. So probably needs to have another event, and maybe have even a series of them, because the topic is really broad, and I think there is a lot of attention just looking at the number of people who are submitted for this event. So let's continue in the future. And bring some more insights and to talk about experience.
I definitely feel we need a follow-up discussion on that.
Yes.
on this topic.
Yeah, you can talk about legacy entirely for an entire session.
Yeah, that's absolutely
Yeah,
true.
I guess a lot of things.
Yeah, integration is a very interesting topic as well. So yeah, but let's wrap up for today, and that was cool.
Thank
Thanks,
you,
guys.
guys.
Okay.
Thank you very much.
Thank you. And
Thanks everyone for joining. Yeah,
until next time.
Yeah.
Bye.
next time.
Bye.